We actually developed an optical modem for underwater communication. It actually uses light because radio waves like your cell phone or GPS or walkie-talkie just don't work underwater. So you need to use something else, and in this case we use light.
Generally, if you want to connect to underwater devices, you have very few options. So maybe you have to plug in a cable, which is very difficult to do, or you would have to take the whole device up to the surface to get the data out. So with the optical modems, you have a wireless connection like Bluetooth or Wi-Fi. So you can just come into the range and then it starts communicating. They can exchange data at a very high speed. So the modems are rated down to 6,000 meter depth. So we use a technique where we encase the whole system in plastic, so it's molded all into one piece. So we don't build a pressure cylinder with air inside that could get crushed at these depths. And that way we can get to these great pressures and these great depths without worrying about the electronics.
There's lots of applications. We certainly have clients in the research space. There's also lots of clients in the oil and gas or just subsea construction space in general. And there's now more and more underwater construction, for example, when you want to install wind parks offshore.
So here we have the data logger, the sensor, and we have our optical modem. And so we're connecting the data logger with the optical modem, and all of this will go underwater. And then the other modem will be attached to the ROV, to the robot, and that will then be able to communicate with the modem here to read the data from the sensor.
The modem converts the data that comes in into flashing light, and the other modem on the other side converts that flashing light signal back into data.
So we use blue light for the Luma modems because water absorbs radio waves and other colors like red or infrared is absorbed very quickly, while blue and maybe a little bit of green light can pass for long distances.
Ok, j'ai la vidéo. Là, j'ai le sonar, c'est bon.
The difficult part is to get a long range with this optical technology because the light very quickly dissipates if you want to communicate over long distances like 50 meters, 100 meters. So we spend a lot of time making a very, very sensitive receiver that can still pick up very small light pulses even over a long distance.
As scientists, we have a big challenge is to understand what's happening below the water. And when we install instruments below the water, we don't know how they are, and we don't know if they are measuring, and we don't know what's happening, basically. And with this robot, we could go down and in real time see really what's happening, and correct if it's needed, reinstall it if it's needed, and that will really help with research.